Every single day, modern human civilization consumes tens of millions of megawatt-hours of electricity to keep servers humming, factories producing, and our global infrastructure online. Historically, generating that volume of power requires extracting and burning billions of tons of fossil fuels, filling the atmosphere with massive plumes of carbon dioxide and industrial pollutants. An alternative source already surrounds us. The atmosphere is constantly in motion, providing a limitless, clean supply of kinetic energy in the form of wind. The engineering challenge lies in the nature of wind itself. It is a raw, chaotic, and entirely invisible force. You cannot easily trap or store a gust of air. Modern wind turbines act as highly precise physical translation machines, built specifically to solve this problem. They force chaotic, invisible air currents into a tightly controlled cascade of mechanical energy. The process begins hundreds of feet in the air with the turbine blades. Some of these structures stretch over 300 feet long, sweeping an area larger than multiple football fields. These blades are sculpted to catch the air. As the wind flows over their curved surface, it creates a pressure difference. The higher pressure underneath pushes the blade upward, initiating movement. This is the first crucial translation. The chaotic, linear flow of the wind is forced into a steady, controlled rotational kinetic energy. From the outside, the massive blades are the only moving parts, but the actual energy generation happens inside the housing at the top of the tower, known as the nacelle. The spinning blades are attached to a central hub called the rotor. This rotor locks directly into the main drive shaft, forcing this heavy steel cylinder to turn in tandem with the blades outside. But there is a mechanical deficit here. The main shaft is only rotating at about 15 to 20 revolutions per minute. While it carries the immense physical weight of the wind, this slow rotation is practically useless for generating grid-level electricity. To solve this speed deficit, engineers route the slow-moving main shaft directly into a gearbox. The gearbox uses mechanical ratios to multiply the speed. A massive gear connected to the slow main shaft locks its teeth into much smaller gears. One rotation of the large gear forces the small gears to spin dozens of times, exponentially increasing velocity. This rapid rotation exits via a secondary high-speed shaft. Now the turbine turns this high-speed rotation into electricity via electromagnetic induction. The shaft feeds into the generator, spinning a large set of powerful magnets. These magnets rotate rapidly inside a stationary cylinder lined with heavily wound copper coils. This magnetic movement physically forces electrons to flow through the wire, creating steady electrical current. The internal conversion cascade is complete. Mechanical kinetic energy has been successfully translated into raw electromagnetic power. This newly generated electrical current immediately exits the generator, traveling down heavy cables routed through the hollow center of the massive turbine tower. At the base of the tower, the current enters a transformer. The transformer's job is to massively step up the voltage of the electricity. This high voltage ensures the power can travel long distances over heavy wires without losing its energy to heat dissipation. Leaving the wind farm, this high-voltage power merges into the vast electrical transmission network, flowing through thick lines suspended across the landscape. This network bridges a geographic gap, physically moving power from the remote, high-wind corridors of coastlines and plains directly into densely populated regions that demand it. Upon reaching a city, the electricity passes through local substations. Here, the voltage is stepped back down to a safe, usable level before flowing into the local grid to illuminate streets, run hospital equipment, and charge the devices in our homes. It is an uninterrupted, continuous physical journey. The chaotic push of atmospheric gust is methodically tamed, accelerated, and converted until it emerges as a glowing screen in a living room. This exact sequence happens entirely without combustion. No fuel is extracted from the earth, and no carbon is released into the sky. By mastering this mechanical cascade, from blade to gearbox to generator, we have the ability to sustain our deeply electricity-dependent civilization using the silent, infinite force of the breeze.
For more amazing science content, like, share, and subscribe to Scinova.